Hello and welcome. Welcome to episode 5 of the Elm Interpreter we're working on in Swift. Today we're going to hopefully finish floats and then start working on some spaces. I think maybe we'll do some work on the input stream first, but we'll get there. So this is just some starter stories I've got. We've mostly focused on literals, just integers and floats so far. Hopefully we'll finish floats today though. We've done some parser combinators, which parser combinator takes a parser and makes another parser out of it. So we've got several. We've done a little bit on the abstract syntax tree. I don't know, it may not be the right word by the time we get done, but we want to be able to interpret the code. So we're parsing it into a tree, and then we'll run an interpreter on that. And we've got a very, very rudimentary one right now. So far, we've done integers. We've got a match combinator that takes either a function or, as of yesterday, it can take a string as well. We've got a many one, which is many is one or more. We've got combine, which takes a function of an array of parsers and combines their results. We've got sequence, which puts them in order. This followed by that, followed by that. And we've got optional, which says 0 or 1. We've also done floats. We've got so far digits.digits and digits.digits digits, so the exponents. And today we'll hopefully finish floats. We'll move on to we'll include an any combinator, which means pick one. It's alternatives or I don't know, one of, I don't know, you can think of different names. And we also want to do the float interpreter, which will be pretty trivial, I think. Been burned before. Look at maybe character view instead of string. And then I think, assuming we get that done, we'll move on to spaces and comments. I should probably I'll add that on there. Oops. At least we'll have that next time to remind ourselves. Okay. Let's see where we are code-wise. So I just ran tests. We at the last minute yesterday, we modified our test to basically use this little helper method, and it takes the string that we're parsing and an expected value, and runs it through our parser, and then compares it with an accuracy level of I don't know, was it 6 or 7 zeros there. Make sure the type is right, and make sure that the rest of the string is right. So let's go back to the parser. Just to kind of frame things a little bit for starters, we have this structure that's a parser producing somethings, A's. You give it an input string, and it tries to peel off an A and tell you how much what part of the string it didn't use. So it reads the front of the string, does stuff, and returns the A value if it can. If there's an error, it returns nil, and that's the question mark. So it's potentially returning nil. I don't. I mean, that seems like a very primitive way to handle errors. Let's put it that way. But it's the starting point from the papers I've been reading on combinators. I'm sure there are real ways they do it, because this won't make it. All right, the other change I made is I put the chat window over here on the right, and hopefully I have a habit of missing the chat messages. So if you're here, say something if you want to introduce yourself, and if you see me doing something crazy along the way, help me out here, because I get lost often enough. All right, so we left off a failing test to conveniently get ourselves going, and what you can see is we got digits.digits. We added the exponents, and here I'm doing two things, and I don't think that's I think that's probably harder than it needs to be. So let's take this. Let's deal with the upper versus lowercase. I'm sure this test will still fail, because I'm pretty sure we just handled lowercase e. And the reason I'm pretty sure is because we don't have a combinator that matches don't have an or combinator or an any or a pick one or one of, however you want to call it, something that says this thing is okay. We could, I mean, we have alternatives. We could make a match ignore case kind of function. We might be able to put a, I don't know if we could put some sort of modifier parser on there, but by the time it knows what it's parsed, it's too late to modify it. So I don't think that's going to quite work. We could, well, okay. We have a failing test. Let's get it passing. I think we have a version of match that takes a function. So I think we can pass a closure in. Like, I think we could do this. And let's see if this runs. Cannot convert to expected argument type parser of character. This thing will have to do that, I think. We have this ongoing challenge of when are you producing single things and when are you producing arrays of things. And the old one, the match string, produced an array of results. And so we'll have to, I don't know, only is maybe not the right word. Maybe it's as array is better. Okay, but I think we'll find that the same test is failing, right? And the reason is we got the uppercase E, but we can handle that in the matcher we were just in. We could say it equals lowercase e or it equals uppercase E. And maybe we'll go there for now and then refactor our way out of it. So instead of being stuck like we were on the other ones, okay, run them again. For the ones like with the sequence, I basically had to put the test on hold and go implement sequence and come back. This one, I'm running it. I'm doing the work in the matcher function, and instead of in the parser. But now I'm in a green bar, and so it's always nicer to refactor from a green bar, even if what we're doing is kind of a replace algorithm kind of refactoring. At least I got an algorithm to replace, okay, rather than just saying like, here's my speculation, I think I want this, and then finding out whether I do. Okay, so I don't know, we can go with this. Yeah, I'm not sure when to refactor. Let's see what else we got going. Float tests. Okay, so e.digits plus digits. Right. I mean, we can get the other ones done this way. Let's do that. Okay, so let's look at parse digits. I don't know, maybe I can say this, digits dot digits e plus digits. I guess I used that name. This one no longer has a plus. Okay, and I'm going to check float 3.95 e plus 1 is equal to 39.5. Well, okay, let's run the tests. This one should fail. Why are e.digits e digits? Oh. Upper E digits? I don't know. Okay, so this one failed. It couldn't parse E plus 1. The reason it stopped before the E, it was able to parse 3.95, but we wanted an E and digits, and it just couldn't. Okay, so let's add that. So we got our E, and now we can do a match on, let's do it this way, $0 equals plus. And again, we'll have to do only. Okay, and I think this will pass. I had two things. Wow. Whoops, this should be optional. Let's see, somewhere I have our grammar. Grammar. Okay, so we just did E. I guess this grammar is not quite right. This question mark should not be there. If you're going to do this E thing at all, you have to have an E. Okay, but the plus or minus is optional, and one or more stars. So the whole thing's optional. Okay, let's make our grammar right. Okay, so we got E or E is required, then optional match of a plus, followed by matching digits, which are required. You can't say 3.2E. You got to say 3 or something after that. All right, let's try again. Okay, and then let's do parse digits dot digits E minus digits. And if we do 39.5 E minus 1, normally we'd go out, it would grow by 10, but minus takes us the other way, so 3.95. Moving the decimal point 1 to the left with minus. Okay. And we'll certainly fail this one because we're looking for a plus. All right, and again, stop before the E. And these are kind of easy at this point. Once we've got all our parser combinators in, things will get simpler too. Okay, so what if we see a plus or a minus? And you can see, I mean, the structure of grammars is really kind of like the structure of integers, as far as there's a plus operator in integers corresponds to the or bars, the alternation, the one of in grammars. Okay, so it's kind of the same operator. And I don't know, I saw part of a Haskell thing or somebody quoting Haskell things for that, and they've got operators that look like operators that it would be plus and times basically. The times is the sequence operator. Okay, because we can sort of multiplying strings is kind of like concatenating them together. So it's an analogous operation. All right, should pass. All right. I've been bad about this. I do keep this to-do list, and it's kind of a stack of stuff we want to do, along with a trailing. You know, after here is these are done. Okay, and we've just done this story now. Okay, and let's put it in here. I'll say parse remaining floats. Well, the story is parse floats. This is really the sub story, I guess you could say. Fancier and fancier floats. Okay, but before we do interpret, just because I think it's going to be a pain, we're going to introduce an any parser combinator. Okay. I keep wanting to stretch this screen out, but I got to keep that chat there. I don't need this. That's probably give me a little bit. Okay, so we've got our tests. I kind of want to. The other thing I want to do. Well, it's handy to write these tests this way, but I don't think it's particularly I don't think it's particularly enlightening. Maybe I shouldn't say easy. I don't think it's particularly enlightening uh, to to have them one at a time like that. I don't know. I'm thinking of doing this. And my debate is, do I need an explanation parameter? And that's pretty simple. Let's do this. Y equals nothing. Okay, let's run. I gotta be explicit, huh? Live string. Okay. Run these again. And I guess I will add some explanation. Digits dot digits. Digits dot digits e digits. You can see we're starting to kind of approach parameterized tests, I guess, really. Digits dot digits e digits. Okay, and let's go back to our grammar. Kind of have to check each path. So digits dot digits. All right, and then we got e plus digit, e minus digit. We could have covered capital E plus digit, capital E minus, lowercase e plus digit. But I'm okay for the combinations. So we have the three ways. This is either plus, minus, or empty. And we have digits at the end. Okay, so I feel like we've covered the grammar rule with those 5 tests or whatever they are. Okay. And let's just break something. Let's do input. How about, I'm just going to put a digit on the front. All these should break. Huh. 395. Why did this one not break? 395 E plus 1. Well, is that weird or what? Okay. I guess it's a reporting error, not a real error. Okay, let's commit this. Handle remaining floating point formats. And push. Okay. So where I want to go next is this match. See, I drop into my programming language to analyze the possibilities there. And what I'd like to do is I'd like to have something that says pick one. Now it might be nice to have a match that takes a set, and we could do that. I mean, that I could see. Let's Okay, so I think we're going to go over to our parser, and we have match taking a function or a string. Something doesn't quite ring right with me with this string one, but let's keep going. We got the sequence. I think we're going to add, let's see, what's the right name for this thing? I think any is the right name. Like, pick any of these. You got to pick one. All right. And where's our tests? Parser tests. Okay. Let's test. I'm going to move match sequence match. Let's pull these tests, rearrange them a little bit. So here's sequence. There's my two match tests, match functions. Optional probably is sequence is more fundamental, I think. All right. And I think our any is more fundamental. Okay, so test any. So I'm trying to say there's a parser combinator. You feed it a list of parsers, and it succeeds if any of one of those succeeds, and it fails if all of them fail. Okay, so any succeeds with one with only one valid choice. I don't know. We can work on that. All right, but it's going to be somewhat like our sequence tests that we have to rely on something else to do the testing for us. So we'll do this. Okay. So we got a match of a digit, and we want to match on any digit. Okay, and we'll get a result. Okay, now what you should be predicting is the front of the string should match the 1. Okay, so we should get a 1 back. I guess it'll be an array. I think to be consistent, we want things to be arrays. That's a good question, though. Here we are defining it. Okay, and then my rest should be 2, 3, because I'm only peeling off 1 digit. Rest. Okay, cannot convert pi to what? I guess that word is taken. Select. Matched. I don't know. One of reads kind of nice. Or maybe it's any of. How's that? Any of digit. Okay, yeah, we can't find it in scope. We'll have to add it. It's going to have the same signature. And it's called anyOf. And it's got to return a parser. See, here I am mucking with these arrays and not arrays, and something's not right here. Well, if I get a parser that is that, I can return. I'll just return parser sub. Well, let's return. Let's return match of wrong, and we'll add an only if it needs it. Why are you ambiguous? He's a parser of character. Match. Huh. I've said match before, right? No, I haven't really. Okay. Can I say match of character dot is digit? Cannot convert parser of character to return parser of A. Yeah, that's the only thing. Ambiguous. Can I say match of A? Can I especially say non-generic definition? Match. Well, he's not generic. Yeah, fair enough. What is parser of character? Match is a parser of character. Only. Where do I add only? I don't know. Can I say only of A? I'm not quite sure what I have to do here. Sorry. Can I specialize in non-generic definition? Well, I'm just trying to create a garbage one. Let's try this. Sequence of match of characters digit. Should produce an array. Oh, golly. Cannot convert value of parser character to expected argument type. Parser of A. Huh. Well, I can return. I can return parser sub-0 and just break. Okay. Is that going to be? Well, this is confusing to me why I can't access these functions. Got a bunch of. Okay, let's run tests. Oh, yeah, we need an exclamation here. And what do we call this? I did go with anyOf, yeah. Okay, yeah, boy. All right, because I returned the parser it holds, which is the same as doing it. Any with one parser succeeds with only one valid choice. Succeeds with valid input. I don't know a good way to make that fail. Let's go to the next one and we'll see. Maybe we don't need as many tests as I thought. Test any with one parser fails with invalid input. This is more of a guardrail test because it's going to pass. Okay. Since, oh no, it will fail. This test will fail because I didn't put a non. Okay, it came back with 1. Let's put an X on the front, and it should fail. This is not what they mean by a failing test. It's the code that's supposed to be wrong, not the test. Okay, unexpectedly found nil while unwrapping an unoptional value. Oh yeah, can't have that there. Okay, so we got a couple guardrails, I guess. All right. So any with multiple parsers succeeds if any succeed. Okay, now it'll be interesting. Let's do this. We'll just pull this. I know these tests are a little too similar for me again. All right, so we match character. Let match any of digit or A. Okay, and if we parse A23, all right, so we expect the parser to try the digit, fail, try A, pass, and return it. Okay. This test should fail because it'll only try the first parser, which doesn't work. Okay. Yep. And let's go in here. Okay, so now we're going to return a parser. Let's get this junk out of here. We'll return a parser of resulting in arrays of A with some input in this. Okay, and I think we're going to do, well, we just have to return the first one, so I don't think we have to be quite as fancy as sequence. But we'll certainly do parser in parsers. Okay. And let's see. So we need to check. Yeah, it's gonna be similar, except not quite. Okay, so we'll parse it. If it's not nil, we're going to parse the input. If the input is not nil, then we're going to return parse result. Okay. And if we get to the end, we're going to give, nobody returned yes, we're going to return no. Okay, so well, let's return parser sub A just to make sure, or parser 0, just to make sure it blows up. Oh, we're doing parse results. Nil. No, I'm gonna hard code a junk value. Return empty array with junk. Okay. So instead of getting a parse result, which can be broken up into a pair, if we get one, we're going to return it. If we don't get one, we return junk. Okay. Now our test should pass. And then we'll do another test that gets rid of the junk. Oh, so much for that. Any with one parser fails. Oh, okay. So yeah, we do need to return nil to make that one pass. Cool. Whoops. Ugh, this editor just does not work the way I'm used to. I think they changed some of the interpretation or something. Okay, return nil. Now all tests should pass. So we passed one, failed one last time we did the reverse light. Okay, and now we're going to write a test that we expect to pass. But just to kind of make sure the coverage is there. I'm going to parse A, but I'm looking for a digit or an A, but I have an X. Okay, and this is parse result. Let's see if I can do this in one try this time. Assert nil of parse result. And this goes. Okay, test ending with multiple parser fails if all fail. Okay, and I guess I can put this back temporarily just to make sure again. Some garbage here. All right, I should get 2 failures now. Yeah. Fail with invalid. Okay, so let's undo that. All right, everything's passing. I guess the thing to notice here is we're basically, if you match, we always start you back at the front of the input, okay? Whereas the sequence, it has to match the first one and then pick up from where that one left off and so on. That makes a difference. Okay. All right. Let's push. Okay, add anyOf combinator. Okay. Well, normally we take a break every 35, 40 minutes or so, and this is probably a good place to do that. I think our next step is let's use that anyOf parser here and get that grammar using the tools of the parser, not implementing it in our language. Okay. We'll come back and do that. So 2 or 3 minutes. See you then. Hey, welcome back. All right. So we wanted to work here instead of match with this inside. We want to make a anyOf with a match of E or a match of capital E. I don't think we need the only because we return an array. Okay, you like that? Let's run. Should all pass. All right, and then this same deal. anyOf match plus match plus match of minus. Drop the only. Am I balanced? And run. I feel like there's probably a good helper for this already. We're gonna see more of it too, right? Because we've got at some point we're going to do identifiers, and they're going to be letters or digits and stuff like that. We'll tune this as we go, but I do think our grammar will evolve a little. But I guess what I like with this, more or less, you can see it's matched character many, match dot only. I guess I can do this. Drop the only now. We're getting a little more sophisticated. Followed by many digits. I don't know. Maybe we'll have to see these operators. I almost kind of like the way it would read better if it said many digits dot many digits. Yeah, okay. We'll come back. Okay, let's see where we are on the... Let's see. Did we run those tests? I think we did. If they pass, we'll commit. Okay. And our to-do. Introduce, well, this is the anyOf. We've done that. Okay. There's, well, okay, let's move on. Interpret floats. Okay. Yeah, so floats, we got interpreter tests. Okay, so interpret number is going to be very similar to interpret float. So we have, Elm Parser has this float type. Whoops, I want the Elm types. AST. Okay, so our primitive AST that isn't really a tree yet, it has integers, holds the values, has float, holds the value, and the Elm type. All right, and so our interpreter test, if you give it 739, let's do 42.5. Okay, this thing should come back with float. Okay, because it knows the type. Okay, so the value is being evaluated, so it gets parsed, turns into the AST, and the AST holds that Elm literal value of 42.5 double. Okay, and it holds a type of number, and we expect the value here to get interpreted and then the type to be interpreted. Okay, and this will fail. I'll be surprised if it doesn't. Right now I think we totally ignore. Yeah, we totally ignore this thing, right? So Elm float not supported. That is not what we expected. Elm float. Huh. I didn't get that message before. Okay. We're going to get the number and the type. Okay. And we're going to append their output. Okay, so Elm float will get the number, get the type, and we're going to write the number and the type. I think that's all there is to it for now. Oh no, what did we get? $42.5. Oh, I must have to do some sort of, can I say number of double? Or maybe I have to, no. let's see. I'm going to look for Swift string interpolation format. Yeah, base double in a string. That's not what we're seeing, is it? .23.000. What happened there? Well, this is weird. Did it not let me do that? What was the problem there? Expected comma separator. I don't think this is. Wait. Was it? No. I don't think there's an issue of scoping, but just to be careful. Hmm. 42 float is not equal to 42 number. Oh, haha. Let's try it with float literal, shall we? Okay. Let's do that again. Oops. Unexpectedly found nil. Type string of value. Okay. Elm type number goes to number. Elm types dot float goes to float. Okay. I mean, it didn't take an hour or anything, but it took longer than I thought. Okay, number and number, just to get things unified again. Okay. So we have, I don't know, did I say this? We have the equivalent of a calculator that doesn't have any operators right now. So you put in 42, you get 42. You put in 42.5, you get 42.5. But the real thing is, notice our tests, we are parsing based on this value. And you have to know which parser you want. Now, that was fine when there was only one, but now we want to be able to make an expression that's either one. So let's update our grammar. Let's see, is this a new test? Where would this be? It's an Elm test, really. Yeah. Okay, so we have integer literal and float literal, but I think we need an expression. And it's going to start primitive, but we're starting somewhere. So I would like to be able to type either 42 or 42.5 and get the right type back, just like I would in my normal REPL. Let's see. So 10. So let's find our Elm Parser tests. Oh, well, I guess I can commit this. Interpreter supports float. Float. Okay. All right. And now Elm Parser tests. Oh, I don't have an actual Elm Parser test. It's hard to know how big these things should get. Well, expression is going to get plenty big, so let's not worry too much about that. Unit test, yes. Let's do expression tests. Yes, there. Okay. Testable import Whelm. And we're going to do a function. And this is test integer expression. And let's borrow our integer tests. Yeah, so parse literal. This is harder than I want. But that's the way it's going to be. Okay, instead of integer literal, we want expression. We may refine that name over time, but let's parse 42. 42 plus, no, we want 42 something else. So let's just do 42 space. Okay, that should be a primitive expression. Its type should be Elm integer, number type, and this should be a space. Okay, and Elm Parser has no expression yet. Let's add one. And this is a junk. So we're saying a parser for expressions is, why don't you try and match an X, which is not. Well, for the tests we're doing, it's not going to work. All right, so let's get this over here. All right, and run this. Elm integer is not a member of type character. What's on our parser? Or no, our Elm parser. Oh, we got to combine. Okay. Well, we'll do combine. I don't know how this will go. Combine characters to Elm float. Oh, still not gonna like it. Cannot convert string to bool to expect to type string. Is that gonna work? Okay. I'm just trying to get a clean fail. And it should fail to parse because it should get a nil below up here. Yeah. Okay. Elm parser. So really, we just want to do integer literal for now. All right, and this should pass. Okay, and then if we do a floating point expression, still parsing expression, but we want to do 99.7, well, 98.7. And this thing should be Elm float. Number type should be Elm type.float. This should be 98.7. with an accuracy of that and that for the rest. Cannot convert double. Expected argument type string. I think maybe it's not caught up. Cannot convert double to expected argument type string. What did we use before? Float tests. What number? Expected isn't double. Assert equal double. Double. Accuracy. Oh, I didn't use the word accuracy. That would have been a helpful suggestion. Just saying. Okay. Should fail. Okay. Should only be Elm float. We got an Elm integer. We didn't parse off the 0.7 because our parser doesn't know how. Okay. And now expression is any of integer literal or float literal. Oh, come on. Can I pervert any of? Oh, do I get tired of this? Yes, I do. This is what I mean when I say there's something funny at the bottom of my chain here. Parser of AST to expected type parser of bracket A. Okay, let's take this one out. Cannot convert parser of AST to expected argument type parser of A. This is a parser of. Why does my anyOf care? Oh, yeah. I don't think anyOf should care. This is we're getting at something here. See this array thing. It's messing me up here. Because I want to be able to stack these things up. So I want to be able to make one combinator takes a parser returning A and it turns it into a parser returning ASTs. So my, where is this thing? Elm Parser. My literal here, when it calls combine, it's the front half is a parser producing an array of these things, and this combines them into one value. But anyOf shouldn't have to care, and maybe I just have to make that the case. Parser anyOf. I think maybe this is what he is. anyOf is going to return a parser, and this all right, let's see who breaks when we do this. We're going to have to put some adjustments in because people are expecting arrays or not arrays, or oh, no, my test failed. So much for that theory. Failed. Should be Elm float. Blank is not equal to 0.7. Oh, I modified my parser. Where's literal or float literal? Okay. Should only be Elm float. Elm expression. Okay, why did it not? Oh, I got to be pickier. Oh, yes. Okay, this is interesting. With this parser like this, it it what went wrong? Yeah. It it's sort of a question of how greedy are things, and the problem is float literals are much greedier than int literals because float literals can be int literals with stuff on the back. Okay, because float literal can be 5.7, but from the front, 5 looks like a perfectly good integer. So this order matters, and that's kind of a consequence. Yeah, I mean, I guess it comes down to order is going to matter with this. I was going to say it lets us back up, but it doesn't exactly. It finds a good match, but it doesn't find the greediest match. Because when we do the anyOf, we don't go through and say, okay, everybody who matches raise your hand. Who's the longest, or some other rule for who wins? We just we just take the first one that comes through. And all right, so instead of talking, I should see it pass, right? You'd like to see that part. And what's two failures? There must be somebody else who cared about that array missing. No, okay. Yeah. Oh, two failures in the same test. Okay. So yeah, that's going to be one of these things we have to pay a little attention to. So when you write a grammar, you don't worry about that. What you usually do, um, I think we call it a corner. What do we call that? Left. Well, basically, we have two rules that start with the same prefix, and so you can redefine your grammar so that let's get a potential integer followed by and if it's an integer, it succeeds, but if it's got dot and this, you keep going and you look for the rest of it. Normally that's the stuff the scanner does in a compiler, but this combinator method we're using, we're mixing the scanning and the parsing together, treating them as one thing. Good or bad, it's probably potentially a little slower. I mean, I'm sure. Do we ever have to back up in this? I guess when we get sequences, if we have an alternation of sequences, one sequence might go down the ways and say, "Oh, I failed," and then the next one goes down the same path and succeeds. That's fine. Where usually in a grammar with the scanner grammar, it's a regular expression basically. Almost always. I mean, there's twists, but if it's a regular expression, we can define it deterministically and don't have this problem. Okay, all right. But we have made it better. Okay, so let's test our interpreter. Sorry, I usually turn that off. The insurance people will have to wait. Okay, so test expression. All right, and now instead of float literal, this is expression. And we expect the same result, so I'm going to keep the same values. But now we're parsing it with a more sophisticated rule that would accept integers or floats. And let's make sure it works. Okay. So I think, let's see what we've done. We did interpret floats. But we also added a story that's like story parse and interpret expression goes to float literal or int literal. Okay. Yeah. Minimal. but I mean, it's kind of coming together a little bit. I think we haven't dealt with the type mismatches and stuff like that, but we can't get them so far, so that's okay. All right. Let's see. So, I think let's come back in here. So one of the things along the way, we kind of extracted mini map and combine. We extracted them kind of from our stuff as we went along, and we kind of skipped testing. So I feel like that should be our focus for a little bit. Um, I try not to get too far behind on stuff like that because what'll happen is you start relying on it, and then it's got a bug, and you're getting a weird failure. You can't tell why. Well, it's because your primitives are messed up. Okay. Let's see. So, um, let's see what we have. Okay. So we got match. We tested match. We tested sequence. We tested anyOf. I think we tested optional. Optional. Okay. We haven't tested the rest. Okay. So here's only. Now, I can't say that's so simple. It needn't be checked. Yeah, so I mean, this thing only is doing this move to wrap out a single parser, a singleton parser into an array parser. Yeah, boy. I guess what's going to happen is most times your sequences are going to get wrapped and then combined before they come out. Okay. And this is where the type checking is helping us. It's just confusing to me, but it is making a difference. Let's get our Elm parser up. Elm parser. Okay, so in here, notice Elm integer literal ends with this combine call that produces an AST. And so we've got all the front stuff is parsing in the character domain, and then we switch it to this domain. Same thing here. Lots of characters, and then we do a combine. Okay, so did we not? What's okay? I guess I didn't commit my expression stuff. Handle primitive expressions. The expression goes to float or int. All right, and then the test. Put that there for now. Okay, let's see. Back to our test. We did optional. I guess I want to test only. Okay, so only, it's an extension on a parser. I mean, the type almost does it. Yeah, we've really implicitly tested this. That's why I'm struggling a little, but I don't know. This thing is going to get simpler. Let's see. Um, hmm. Many one is really the self followed by I don't know. Right. I mean, a many one is really a self followed by a many, and many is an optional or a many one. So there's a nicer combination for that, and the reason I know it's there, I mean, we haven't looked if we can simplify this one, the sequence, but sequence is doing this work, and here many1 is doing the same kind of stuff. Because it's a many1 is really a sequence of yourself plus arbitrarily more, 0 or more. Can I do that? What would that look like? Okay, let's test first and then worry about it. Focus. Okay, so a parser test for only. Let's do that. Okay, so function test only produces array of 1. Okay, so a parser is match x dot only, and we'll let the result x, etc. The result should be equal to the array x. That's array, and then rest should be equal to space, etc. I guess clarify things a little. Okay. Additional character. Oh, we must unwrap. Yeah. Okay. Whoops. Array of type string to array to character. Just a type issue, I think. No? Okay, an X matcher let's see. Oh, match of that produce. Let's go to characters digit. One of these returns an array and one of them returns an individual item. Okay, but this should pass. Oh, okay. Parser of X. Oh, digits. Yeah. 9, 9, etc. Okay. So only produces an array of 1. Now the other thing I'm seeing in here is match. Our match probably can be simplified, rewritten. This thing, matching a string, should really be a sequence of matches of the individual letters of the string, if that makes sense. And then, I don't know, this stuff might go away. So, let's see. But, well, how's our theory going? Okay, so we tested only. I guess I'll put this in to-dos. We backfilled tests for only. Mini, map, and combine. Only didn't even make the list. Okay. Sequence any of optional only, many1, map, and combine. Who calls map? Callers. Nobody? think map, well, it makes sense, and we may need it at some point, but we're not doing it now. I think we used it before combine existed. All right, so let's take that out. There, one less thing to test. Many one and combine. Okay. Let's. What do we got checked out here? Okay, we added a test. Okay. So the proposal I'm making is I want to change the way match works. My theory is I would like to be able maybe I want my map back. Missing return. Okay, so I want to return a sequence of I want to take these strings, prefix dot, is it character values? No. Array of prefix. No, I think I've got to do more setup first. All right, let's comment that. All right. I think what we need to do yeah, array of prefix gives me characters. I want to do match one, maybe. Maybe it's just match of a character. Like if I have this function, match of character of type character produces a parser of characters. Okay. Whatever that was. Okay. This thing could use that, but I don't have that yet, and it's kind of break time again. So let's take a break. We'll come back and see if we can get this match. So I'm going to say refactor make match of string become sequence of match of character. Okay. All right. We'll take 2 or 3 minutes. Hey, welcome back again. All right. So we're going to try this thing of making match go to a sequence of match of characters. So we're going to refactor. How we can say we're refactoring? I don't know if it's a refactor exactly. Well, it's not a by the book refactoring, that's for sure. All right, but I'm saying if I had a matcher of single characters, that's really match of $0 equals character. Okay, so if I want to match a single character, I can certainly call a function that matches just that character. I don't know if that's even makes this worth the making. And I'm going to call it match 1 for now, just to make sure I'm clear on which match is which, right? But we'll deal with that. Okay, so no harm in this, right? I've just added a function, but we're going to switch this thing over. Okay, so let's let array equal array of prefix, and make sure its type is what we expect. Array of element. Okay, I hope that's the character. Let's close this off. Okay, so on the idea I had before, so we're going to take the array of characters, we're going to map each one to a parser, which is a match 1. Okay, so let's see, what is he mapping to? Map of match 1. I think that's what I'm after. Array of prefix to close the parser. Is that going to work? No. Cannot convert string element character to closure result type parser of bracket characters. Cannot pass array of type array of parser of character as variadic. Oh, I can't. That's annoying. I think that's my real issue. I can't. Let's look up Swift pass array to vargs. Splatting is not in the language yet. Use an overload, use a helper. Another workaround, okay. Sum of numbers goes to array of int. Unsafe bitcast, yeah, no thank you. Keep hoping Swift 5 will come up with something here. Dynamic callable with unsafe bitcast. That's a lot of work to avoid an array, isn't it? Can I pass? Now this, again, I'm getting burned by this parser thing, this array stuff. I mean, sequence should take a parser of anything. And return a parser of arrays. But if I do that, okay, I'm going to revert. Well, can I? Yeah, let me revert. Okay. Have courage. Yes, I do. Okay. So now my question is, as I look at this, like, why is this type not? Oh, golly. What I really want is I want everybody flattening their types along the way, but I wish the type was this. You give me a bunch of parsers, I will return you a parser. You give me a parser producing A, I'll return you a parser producing array of A. Cannot assign a string to array a string. I guess this is another experiment here. Okay, value is of type A, and this is just result.append value. Right? I mean, that's kind of what I want, but it's like somewhere, if I have a sequence of a sequence of a sequence, I still want just a flat set of stuff, and I'm not sure I can get it that way. Because I'm going to get parsers of sequence of X. Let's do a build, see who complains. It's not a horrible number of places. Okay, sequence. Yeah, so many1 wants to work with anythings, but it's always going to produce an array of them. Now notice my anyOfs. Oh, matches. Those matches take strings. Yeah. Everything's here though, huh? Well, I guess this is where I mostly use these things. Yeah, got 3 brackets now by the time I get it out of 3 levels. Many1. At one point, I was letting it do its thing like that, and then I would call flatten down in here. But I shouldn't have to call flatten, flat map. Do I want a sequence that works for arrays and another that works for single values? I don't know. I feel like that's a path towards like knowing which one you're calling. Let's see if I can even declare it that way. Okay, let's revert this. I'll copy this. Revert this. Okay, I'm back to parser of A's. Let's suppose I had another sequence that was this. Parser of single A gets arrayified. Okay, can I run tests? And nobody's calling this one yet. Okay, so can we... Wait, where's Elm Parser? I gotta think this is an Xcode bug. It's showing me that I'm on the file Elm Parser, but it doesn't show me the actual file. Like, what's up, guys? Okay. Match character is digit. I'm gonna go through the same thing with many, aren't I? See, this is that same issue here. Match of a string, I made that produce an array of stuff. So if sequence is all happy with that. Match sequence of E, anyOf could produce a singleton. Optional could produce a singleton. I don't know who's complaining. I guess I'm the only one complaining, right? I've got this sequence of parser thing. Well, I guess my complaint is I can't just put a bunch of singleton parsers in. I gotta make my arguments be arrays. I don't know. I'm tilting at something. But we were gonna do many one. Okay, so many one is one or more. So if there are 0, it fails. If there's 1, it succeeds. If there's 2, it succeeds. Okay. Test many one fails if parser fails. I'm almost... These assertions, I would really love to just make something... Just make a simple assertion. Let's see if I can put this inline again. Okay. It's going to be a many one. And all right, this should pass. I guess all these are passing if we're backfilling, right? Okay, many one succeeds if parser succeeds once. I believe that will pass. Oops. Many one succeeds if parser succeeds multiple times. Well, that idea is going to go on hold. Oh, I guess that's why I wanted the sequence. Okay. Backfill tests only. Many one. JavaScript. No, we're writing an Elm parser in Swift. I'm gonna ignore the JavaScript problem of Swift or of Elm. it's mostly a framework for me to, or a, I don't know, a domain where I can just kind of learn about parser combinators and learn about Elm and keep learning about Swift. At some point, I think things like HTML and all that, I'll probably have to translate into Elm, the Elm calls to those into corresponding Swift calls. But I don't know what the ports and all that stuff is going to be. Ports is their JavaScript interface. I may have to come up with some analog. We're a ways away from that, as you might guess. Okay, so we're backfilling some tests. We did many one, which matches one or more things. And that's good. And then we got combine. Okay, so combine, you give it a function. It takes, let's see, it's a function that takes an A and maps it to a U. Okay, so let's see our example of that. Elm Parser has it. So Elm Parser, it matches many characters that are digits, many one or more, and then it combines them to characters to Elm integers. So it gets an array of characters and produces this internal interpreter type. All right, back to here. So we want to test the combine function. And I don't think he's designed to fail per se. Oh, if your parse failed, it fails. Otherwise, we get the result out and we call our function on it. So I guess we need to check if the parser fails, combiner doesn't do anything. Combine fails if parser fails. So isDigit.combine with a function that says take each character and, I don't know, can I just say combine plus? The characters, no, string. Type character of string. What converts a character? I don't want to after an operator that converts to string. I think I can just call string on it. Yeah, just call string on it. I don't know how do you do that in string. I don't know. You do something like that in Java, right? Is that put in a closure. Convert is not possible. Just define a new function wrapping the call. Ugh. Is there an identity? I just want something. I don't even. Can I call this thing characters to Elm integer? Just to get something calling. Cannot convert character to bool to expected argument type string. Only. All right. The result of calling parser.parse on anything. Oh, well. Non-digit should be nil. Maybe, yeah, I'm kind of cheating a little bit, grabbing a function out of here. Maybe I should just define my own little helper function. Let's do that. Characters to, let's just do characters to string. Return string of input. Okay, should still pass. Okay, and then let's do one with succeeding. Character is digit. We will parse. Combine succeeds if parser succeeds. Okay, so we get a digit. Let's do many one. And we'll parse 321 x. We'll say let result. I guess we can say let what's this? Result rest equals this. And we're combining it into a string, so we just expect the string 321 from the result. And then we expect the rest to be x rest. Okay. And yeah, we got to unwrap it. Okay. Cool. All right. And we deleted that. We did many max. We need combine down here. Okay. Commit test combine. Okay, now I'm ready to go back to this thing, this sequence stuff. Ugh. Okay, so I guess my claim was I would like this function in a version that takes single parsers. And I feel like I've run into places already where I need this to happen. My value is A, this is just that, and yeah. All right, new function doesn't affect tests, but we're going to call it in our other one. Now, can I fold these somehow? That would be the trick. Okay, but if I had a match, so somehow I want this thing to return a sequence. Whoops. My theory was I would return a sequence of, I'll take the prefix characters. If I take array of prefix, I get the characters. I want to map each one to something, which is a match 1. Okay, and we'll define match 1. Ooh. Match 1 character, and he's going to return me a parser of character. And he's going to return match of $0 equals character. Cannot convert value of type nothing. Let's call this sequence 1. Again, I think I can get them folded together at some point, but I think they're getting confused. No, it's me, it's confused. Can I convert value of type nothing to closure result type parser of character? Well, let's pull this out and see if it makes any more sense separate. This, and then we'll say return sequence 1 of lists parsers equals. Okay, and I guess I'm also getting burnt by this. Contextual type for closure argument list expects one argument which cannot be implicit. Okay, so I want is that true? Okay. Does it work? That's question 1. Okay, can I inline this? I should be able to say $0, match 1 of $0. I don't know why I couldn't just pass match 1 as an argument though. Okay, now I can inline this. The function is $0 equals ch. If I inline it, I got $0 equals ch. Well, ch is supposed to be my current $0. So I'm trying to decide if this is better or worse. Better, you know, the eye doctors. It's nice that I'm not doing that line 29 crap. Peeling off the array of input is taking my whole input, turning it back into a list of characters, turning it back into a string after I chop off the front. Like, ugh. Yeah, so this, well, I think it's better. I still wish I could inline match 1. Also, I'm wondering if I say call this sequence, can it tell them apart? It should be able to. One's an array and one's a list of items. Okay. All right, so I think this much is an improvement. I want to map each one to a match one call. Maybe I was better off with CH. Maybe this makes more sense. CH in match one of CH. Okay. Match one of CH is this. Where $0 is the future thing being tested. I think that's okay. I don't want to need match one if I can help it. Okay. Now, can I combine these two sequences? Oh, they're so darn similar. Input, result, value. It's just the value. Yeah, it really comes down to this line. Okay, can I return? What I'd like to do is return sequence of parsers and cut all this. Does that work? No. Cannot convert value of array of parser of arrays. Parsers producing arrays to argument type parser of A. How do I get that array peeled off? An array of stuff. Yeah, what I don't quite get. Like, why can't A be type array? But maybe that's just. See, this is where my map could come back in. Like, if I could, or I call flat map here somewhere. If I took the sequence. If I took the parsers, I keep trying to read that as parser with an input of this, and it's really parser with an output of that. Okay, if that makes any sense. So a parser of A's. If I've got a parser producing arrays of A. Yeah, somewhere it had to take a flat map or something, but I don't see it right now. That's okay. Ward Cunningham had a nice talk, like, I don't know, 10 years ago or something, but something about waiting for that moment to refactor and letting things just kind of bubble around for a while. I think that's what we're doing in this case. At least I'll tell myself that. This, I think, is a step forward because I got rid of all that ugly manipulation of my input stream. And maybe the input stream is the next place to tackle. That's a moderately big refactoring. Let's just see what the diff is here. Okay, so yeah, we did do that. Let's get that. Make sure that runs. Lock that in source control. So we make match work by calling a sequence of single letter matches. Okay. And I think there's one more match emerging, and I don't know quite how to get it. But we see it in Elm Parser. We have these matches that match letter or letter, letter or letter. Maybe this is a match one. We got the same kind of thing going here. That's a match one. I don't know. Maybe we'd be better off with that. But it would be nice if we had a match that matched a set of characters. I don't know if the syntax to get. Yeah, how am I going to know it's a string versus a set? I don't know that one. Unless I change the name, because it's hard to tell. If I have to say set everywhere, that's a little ugly, because it's got to be a set of an array of stuff, and I don't want to do that. I want to pass a string, kind of like a regular expression with the brackets, that kind of thing. Pick one of these letters. That's there. That's an emerging thing. anyOf match of stuff. But let me start in on the spaces issue. So we're going to go back to parser. Right here, this definition this string here, it's string is not the right name for this. So one thing I've seen is type alias. Well, and I've seen stream, but let's call it input equals string. Okay, and now I can say input and input. All right, this should be okay everywhere. All right, so we're starting a refactoring. Let me get that in my to-do. We did this one. We're knocking off stuff today, at least, I'll say that. Okay, so input stream. I guess this is a refactor, and it's read from input rather than string. Okay, and the deal is our input right now, anybody can, type alias just says, oh, you can use the name this, and I'll just swap in. It's almost like a macro. I'll swap in that. But everybody who calls it, and this is why it's not an easy refactoring for us, because we've got so much stuff already that depends on it. And maybe I should have moved it up in my list, because I knew I had concerns about this. That crazy matchup we got rid of is only one of the things. Really, yeah, here's the down at the bottom, right? when the only thing we have that matches right now, to actually consume a single letter, these two functions are it. And this one calls this one. So in effect, the only thing that knows the structure of our string is this class or this function here, and it knows I can do input.drop first, and I can peel off where's the character coming from, input.first. Okay, so if I made a new type, and I'll just let's see. I guess I'll make a class. I will inline stuff as we go, but I can find out what happens to my class, my input. Okay, one thing we know is there's a first method, and first must return a character. So it's a function first. It's not even a function, is it? It's a var first of character. I guess we'll do that for now. And then there's a drop first. Var, sorry, this one is a function. Drop first, and it produces an input. Okay, and I think this is the place it's getting ugly on me. Yeah, it produces a my input. Excuse me. Let's see. First of character. Can I make an empty character? Yeah. Let's put that for now. This is more my tool to explore things. Okay. So, well, okay, really, my input has to have an initializer. Okay, so it's got an initializer that's a string. Input of string. Okay, and it's got drop first. Right now we're returning input. Well, let's catch it. Our input of string. Okay, so I'm trying to make my own mini class that does exactly what it does right now. Okay. If we take my input and we take input dot drop first. Okay. We're can I convert string dot subsequence? I guess I got to make a string out of it, like we did down there. Okay. I'm accepting this kind of inefficient implementation to get things working. All right. What else goes on? Okay, so let's build this. All right, that builds. All right. Now, everybody else, does anybody else manipulate this thing? They always get it from some other parser, I think. This might be, no, it's coming from a parser. Yeah, so I think as of now, most of the action is really confined to this place here. So if I did this, could I make this substitution? And I think whoever calls the parser is going to have to call it with my input instead of string. Oh, let char equals input dot first. Optional. Is that better? Type of expression is ambiguous. Well, parser of character. Okay, what's the... Oh yeah, I'm saying my input has to be called now. Okay. Anything else? No exact matches to initializer. My input takes a string. Input is a string, so this is not this, it's just input dot drop first. Is that better? Okay, does it build? Does it work? Bigger question. I think, yeah, these people have to say input instead of strings. Parse takes, yeah. I don't know if I'm going to regret this, changing 20 places. Okay. All right, let me build and make sure I'm getting somewhere. These three should be okay. The rest of them should be failing. Don't need that. Okay. Wow, can't type. Rest is the result of parse. Yeah. I don't like this one that leaves stuff lying all over the floor while we're in the middle of it. The thing we're trying to do is get the... Well, can I give it a rest function? Let's go back to our definitions. So the parser is giving you give it an input stream, it gives you the first element off it and then the rest of the input stream. So it is an input. It could give you a rest on there that is the... Yeah, maybe that's the thing to do. Let's put a rest function on there. It's a function rest returns a string. Okay. And it's going to return input. Okay, so drop first, we're returning the string. Yeah, we're returning just the stuff with the dropped stuff. Okay. Okay, let's see. Cannot convert string. That's rest. Rest. I don't know, is that good? Let's see if that builds. Yeah, would that be better to give it an equals? Yeah, I may be back in this code at some point. But we're going to get it converted and running, and then worry about the cleaning. I guess I can look for parser.parse. Replace parser.parse with parser.parse of my input of. I'll replace them all and fix the ones that have extra braces or extras. Now we're missing a brace, right? Everywhere we had that. There's probably a regular expression that would have got me 99% there. But I think these are most of them. Most of our parsers in this file, so this should be most of the errors. Okay. Now we should have all the rests. Okay. If I look for rest, I want to get rest.rest. Okay, so let's start at the top. Okay, let me run this. Everything should be a rest issue now, yeah. Okay. I'm going to find the first one. Replace. Just for consistency here. One more. Input plus. Okay. Run these tests. It should pass. Okay. Is this the first test or the last test? Parser.parse of my input of 98.7 got a nil. Okay, I guess we're going to have to look at parse. Well, let's look at Elm Expression. The expression is anyOf. And let's look at our anyOf and make sure it doesn't have anything that throws us off. Parser of something. Parse result equals parse of input. That gives us a pair. If it's not nil, return it. I don't know. That looks okay to me. Let's break here. Now, how did he fail this early? Well, let's go here. All right, have we done our stuff? Let's see. Does this thing can't be right yet? Yeah, this. If I'm going to implement it, I got to do first as well. And the value here is input dot first. Okay. Everything else I think copied from the other. So let's try that again. Okay, yay. Yeah. All right, so let's say we moved, we switched parser from string input to input type. Okay, now let's see. My goal for this is I would like my input to I would like it to keep track of the index where I'm reading, and if it fails, yeah, I just want it to keep track of that, and then drop first is just increase my counter. All right. Now the next thing I want to do, can I do this? Yeah, let's try and make that change. It's var current equals 0. Is this legit? So I've got my input, I've got my current. I'm going to save my input. My first character, can I return inputs of current? Okay. Cannot subscript string with int. Really? Oh, yeah. What I want to do, yeah, before that even. Input dot first. I don't mind doing some inefficient stuff for a moment, but I'm trying to get it to a more efficient thing, and maybe I just have to let it go for today. But the goal is I don't want this to be string. I want this to be array of character. Okay, and then this should use that. This should just return self for now, but increment that. And then we can decide if we really need to drop first to return something, or if it can just It's handy. Let's see. I don't think I'm quite there to be efficient with it, with what I want yet. Because somebody does need input drop first. They do need the access to the array of characters, and I don't want to be copying these things all over the place. So we're gonna have to do some more work here, but that'll be the next kind of step. Is I'm gonna get this thing converted to characters, and then make it so that it only converts it once. And then when you ask for drop first, you're getting an index and a pointer to this string, basically. We'll get there. But I think we'll pick up there tomorrow. So tomorrow, 1 to 3 p.m. Eastern Time. And I think once we have that done, well, I don't think it's a performance issue so much as just kind of getting these things consistently in terms of characters. Like that's what I really want. I don't want to be copying big old strings around. It's okay when I have 50 characters in a test case, but not so great longer term. But I don't know. Maybe I'm being prematurely optimizing. We'll see. But I'll get that converted tomorrow, and then start digging in on the spaces and comments. I know we did some Elm REPL stuff, and we saw there's some goofiness. Like if you put 42 on a line, you can't put another value like 37 on the same line. It doesn't let you put two values in. I don't know if that's the REPL or the language, but it appears to be you put 42 and it wants to ignore to the end of the line. It doesn't want anything else on that line, maybe a comment. So we'll explore that and figure it out. But tomorrow we'll pick up with spaces, and thanks for joining me today, and hope to see you again in the future. All right, thank you. Bye-bye.